So, we video lecture ഒരു basic clutch design ഒരു problem start ചെയ്തിട്ടുണ്ടായിരുന്നു. അപ്പോൾ അതിലെ first condition uniform pressure condition base ചെയ്തിട്ടുണ്ട് solve ചെയ്തു. Right. നമുക്ക് continue ചെയ്യാം. So, നമ്മുടെ problem ഇങ്ങനെയായിരുന്നു. Plate clutch having a single driving plate. The contact surface on each side is required to transmit 110 kilowatt at 1250 rpm. 1250 rpm. The outer diameter of the contact surface is 30 mm. The coefficient of friction is 0.4. Okay, assuming uniform pressure of 0.17 mm square, determine the inner radius. Right. So the uniform pressure condition direct condition apply ചെയ്യാം. Load acting case എടുക്കുക. W is equal to P into 5 R1 square minus R2 square ആണ്. Finally, നമ്മൾ കാണാൻ പറഞ്ഞിരിക്കുന്നത് inner radius ആണ്. അപ്പോൾ ഡയറക്റ്റ് ഫൈനൽ നമ്മുടെ മെയിൻ ഇക്വേഷൻ നമ്മൾ ടോർക്ക് ട്രാൻസ്മിഷൻ ഇക്വേഷനിലേക്ക് വരാം. Find the torque using this power equation and then and R. Okay, അതിൽ ആകെ unknown ഉള്ളത് R2 ആണ്. Find the R2 value and the value comes around 75 mm. Okay. Now we'll move on to the second part. Okay. So second part, the question is something like this. Okay. So assuming the same dimension and the same total axial thrust. Okay, so that means assume the same dimensions in the sense take radius as same. Okay, same radius R1 R2 to be same. R1 is 15 mm and R2 value we have already found it out 72 mm, 75 mm. Okay. So assuming the same dimensions and the same total axial thrust, that means take the value of W as same. Okay, so we have to find the value of axial thrust. Okay, determine the maximum torque that can be transmitted and the maximum intensity of pressure when uniform wear condition is reached. Okay, so when the uniform wear condition is reached, wear condition. The second part of the question is all about uniform wear condition. So here you have to find out determine the maximum torque that can be transmitted. This is the first part. Okay, so we'll find out that one. And the second part is actually find the maximum intensity of pressure. Right, maximum intensity of pressure when the uniform wear condition is. Okay, so we'll start with the maximum intensity. Okay, so we'll find out the first part. Okay, no. Okay, so let's start with. Okay, we'll start with then with the maximum torque transmitter. Okay, maximum torque transmitter. Okay, so the standard equation for maximum torque transmitter is T is equal to mu W RF, where RF is the main radius and that is nothing but R1 plus R2 divided by 2. Okay, so R1 and R2 value we have already found out, that is 75 mm plus 75 plus, as per the question, it is 50 divided by 2. So for your RF value is 90 by 2, which is 45. Fine. Okay. So the remaining things that you need to find out is mu and W. Okay. So mu value from the question, the coefficient of friction value, you can take it as 0.4. Okay. Mu is equal to 0.4. Okay. Now the next thing that you need to find is axial load. Okay, axial force or axial load W, which is nothing but we have already found out the equation for uniform wear condition, right? So for uniform wear condition, it's actually Q pi C into R1 minus R2. Okay, nothing but Q pi C into R1 minus R2. R1 minus R2. Okay, so here one N is also there. Okay, okay. Q pi C into R1 minus R2. Okay. Now, so we'll find out. Okay, we'll see what are the unknown values over here. So C is something which is unknown. R1 we have the value. R2 value also we are having. Right. So as per the question, there is one more thing. That is from the question they said and determine the maximum torque. Okay, assuming the same dimension and the same total axial thrust. Okay, so the axial thrust is same for both the cases. So here, from the uniform, uh, from the uniform pressure condition, you can actually find out the axial load. Okay, axial load W is equal to P into pi R1 square minus R2 square. Okay, so the pressure value we know that pressure value as per the business pressure value is as per the business 0.17 into pi into R1 is 75 square minus R2 value is 15 square. So upon solving this one, you will get the value for W as you will get the value as 9011 Newton. Okay, to solve this one, you will get it as 9011 Newton. So this is actually the axial load. Now, as per the question, the axial load over here is also same, which is nothing but 9011 mm. Okay, so using this condition, we can find out the value for C, which is 9011 divided by 2 pi into R1 minus R2, which is 75 minus 50. Okay, so substituting this one, you'll get this 9011 divided by 2 pi into 50. Okay, 100 pi. Okay, so for solving this one, you'll get the value of C. You get the value of C somewhere around okay, let it be 9011 divided by 100 pi. Okay, we'll solve it later. Now, so we have already got the value for W. Okay, so mu value we have. So for the torque transmitter can be directly found out. So torque transmitter T is equal to N times. So N is 2 into mu is 0.4 into axial load is 9011 into RF. So the RF value is nothing but 45 mm. Okay, upon solving this one, you'll get the torque transmitted as 811 Newton meter. Okay, so that completes the next part of the question. Okay, so here there are two parts. One is to find the maximum torque transmitter, and the second is to find out the intensity of pressure. Okay, so as the next part, we'll find out the intensity of pressure. Okay, okay. The next part will be finding out the intensity of pressure. Intensity of pressure, small p. Okay, okay. So we know that. So we are actually asked to find out the maximum intensity of pressure, right? Okay. Yes. The maximum intensity of pressure. You will get the maximum intensity of pressure when the radius is minimum. Okay. So this is the condition to find the maximum intensity of pressure, which is P max into R2 is C. Okay. So R2 value we know. C value you can find out using this relationship. Okay. So if you solve this one, you can directly find out the value for C. Okay. Or we can directly substitute over here. So this P max is nothing but C we have it as 9011 divided by 100 pi 9011 divided by 100 pi into radius R2, which is nothing but 9011 divided by 100 pi into 15. Now if you substitute this one, you get the value as 0.2 per mm square. Okay. That is the maximum pressure value. So in short, I'll tell you what we have done is first one was the uniform pressure condition. Uniform pressure condition. Okay. So for uniform pressure condition, we have this equation to find the axial load, that is P into pi into R1 square minus R2 square. Okay. So this equation we have utilized to find the value for W. Okay. Now the same W we have used for the uniform wear condition, because as per the question, See, only can be used only for this question because as per the question there is a condition that is this W is same as 2 pi C into R1 minus R2. Okay. Now, so using this relation you can find the value for C which is nothing but W divided by 2 pi into R1 minus R2. Right. Now, this C value can be used to find out the maximum pressure using this relation P max into R2 is equal to C. For R2 value is given, C value you will get it from here to find the maximum value. Okay. Now, if suppose you have to find the P minimum, if you are asked to find out the minimum pressure, then you can use this relation P minimum into R1 is equal to C. Okay. So, to find the P minimum, it is nothing but C by R1. That's it. Okay. So, that completes your first problem. Okay. So, you can find similar problems in this module for clutch and for the basic single clutch. Okay. So we'll solve one more problem and then we'll move on to the next topic. Okay. So you can take down this problem. A single plate, a single plate clutch effective on both sides is required to transmit required to transmit 25 kilowatts 25 kilowatts at 300 rpm. Determine the inner and outer diameters inner and outer diameters of frictional surface of the frictional surface if the coefficient of friction is 0.255. Ratio of diameters is 1.2. Ratio of diameters is 1.25. And the maximum pressure is not to exceed is not to exceed 0.1 Newton per meter square. Also determine the axial thrust. The axial thrust to be provided by springs. Assume theory of uniform law. Assume theory of uniform law. Okay. So this is your question. So single plate plus effective on both sides is required to transfer 25 kilowatt at 300 rpm. Okay, determine the inner and outer limits. Okay. So unlike the previous question here, you have found out uh, the inner and outer diameters of the frictional surface. If the coefficient of friction is 0.255, ratio of diameters is given, and the maximum pressure is not to exceed 0.1 Newton per mm square. Okay. Also determine the axial thrust to be provided by the springs and assume uniform theory of uniform wear. Okay. So ഇവിടെ ഈ പ്രോബ്ലത്തിൽ assume theory of uniform wear എന്ന് പ്രത്യേകിച്ച് പറഞ്ഞു. In case if it is not set, പ്രത്യേകിച്ച് ഒന്നും പറഞ്ഞിട്ടില്ല എങ്കിലും theory of uniform wear എന്നാണ് ഇവിടെ എടുക്കുന്നത്. കാരണം ഇവിടെ പ്രത്യേകിച്ച് പറഞ്ഞിട്ടുണ്ട് and the maximum pressure is not to exceed. Okay. So average pressure അല്ല പറയുന്നത്. You have to take the maximum pressure. Okay. So maximum pressure വരുന്ന കേസിലും preferably you can go with the theory of uniform wear. Okay. നമുക്ക് അങ്ങനെയാണെങ്കിൽ ഈ ഒരു പ്രോബ്ലം സോൾവ് ചെയ്ത് നോക്കാം. സോ ഇവിടെ again single plate clutch is given which is effective on both n value is 2. Okay, and it is required to transmit a power of 25 kilowatt at an rpm of 300 rpm. Okay, now you have to find out d1 and d2. Okay, both are unknown, but you are actually given the ratio of diameters. So, D1 ആണ് higher diameter, D2 lower ആണ്. So the value comes around 1.25. Okay, and the maximum pressure, yes. The next input is maximum pressure is 0.1 Newton per mm square. Also determine the axial thrust to be provided. So first of all, you have to find out the inner and outer diameters of the friction surface. Okay. So yes, you need to find out this one. Okay. So how do you proceed with such a problem? Okay. So നമ്മൾ എപ്പോഴും ഒരു പ്രോബ്ലം കിട്ടിക്കഴിഞ്ഞാൽ എപ്പോഴും തിരിച്ച് ചിന്തിക്കുന്ന ഏറ്റവും ബെസ്റ്റ്. നമ്മൾ ഏറ്റവും ഫൈനൽ ഇത് ബേസ് ചെയ്ത് ഏറ്റവും ഫൈനൽ ഇക്വേഷൻ അൺനോൺ വരുന്ന ഏറ്റവും ഫൈനൽ ഇക്വേഷൻ തിരിച്ചു വരാം. ഓക്കെ. സോ ഇവിടെ ക്ലച്ച് ആണ് നമുക്ക് ഇവിടെ യൂസ് ചെയ്യുന്നത്. ക്ലച്ച് ബേസിക്കലി ചെയ്യുന്നത് ടോർക്ക് ട്രാൻസ്മിഷൻ ആണ്. അപ്പോൾ your torque transmission equation is this one. T is equal to mu W RF is the fundamental equation, where your RF is nothing but the average of R1 and R2 plus R2 divided by 2. Okay. Now, so here your mu value, yes, your mu value is also given 0.255. Okay, so that value is given. Okay, now, and RF value is the ratio of this one. Okay, now again, so you can take it as D1 by D2 is 1.25. No, R1 by R2 will also be equal to 1.25, or R1 is equal to 1.25 R2 in the parameter. Right. So the relationship is clear, right? Correct. Now, again, uh, uh, okay, നമുക്ക് ബാക്കിയുള്ള വാല്യൂസ് നോക്കാം. എന്തൊക്കെയാണ് മിസ്സിംഗ് വാല്യൂസ് എന്നുള്ള കാര്യങ്ങൾ നോക്കാം. Okay. Now, your axial load. Axial load. Okay. So here, axial load W is nothing but 2 pi C into R1 minus R2. Okay. So C value is unknown, axial load value is unknown, but R1 and R2 the relationship is the R1 is 1.25 R2. So if you substitute this one over here, 2 pi C into 1.25 R2 minus R2, so that will give you 0.25 R2. 0.25 R2 is nothing but 0.5 by C R2. I into C into R2 is your W. Right. Axial load. Okay. Now, and your reaction RF. Okay. So similarly, your RF value is nothing but 1.25 R2 plus R2 divided by 2, which is nothing but 2.25 R2 divided by 2, or which is nothing but 1.15. Okay. Now, random relationship in terms of R2 getty, but there is an unknown which is your constant C. Okay. Right. Now, now we have another radius right. Again, if you substitute this over here, your torque T becomes T is equal to mu value. We know that value, that is 0 point new value is new value is given with 0.255. Okay, 0.255 mu into W is this one 0.5 pi into C into R2 into RF is 1.125 R2. Okay. Now RF, now W, and this is your coefficient of friction mu. Okay. Now still ഇത് സോൾവ് ചെയ്യാനാവില്ല. എന്തൊക്കെ വേണം? നമുക്ക് ലെഫ്റ്റ് സൈഡിൽ ടോർക്ക് വാല്യൂ അറിയണം, അതുപോലെ സി വാല്യൂ അറിയാമെങ്കിൽ നമുക്ക് സോൾവ് ചെയ്യാം. അല്ലെങ്കിൽ സീനെ you can represent it in terms of R. Okay. But we know that your P max into nothing but C. Okay. So, but P max value is given. Like P max value is 0.1. So that is nothing but 0.1 R2 is C. Okay. So let this be my first equation. So second one, if I substitute 2 in 1, my torque T becomes 0.255 into 0.55 into 0.1 R2 into 1.125 R2 എന്ന് കിട്ടും. Right. ഇങ്ങനെ further reduce ചെയ്താൽ അതുപോലെ ഉണ്ടാവും. T is equal to, I'm writing that equation once more. T is equal to 0.255 into 0.55 into 0.55 into 0.1 R2 1 R2 into 1.125 R2 5 2. Okay. So ഇവിടെ right hand side R2 എന്ന് പറഞ്ഞ ഒരേ ഒരു unknown value മാത്രമേ ഉള്ളൂ. Right. R2 എന്ന് പറഞ്ഞ ഒരേ ഒരു unknown value മാത്രമേ ഉള്ളൂ. So if you can find out the torque T, the game is over. Right. So torque T കാണാൻ നമുക്കറിയാം. Your power value is given. Power transmitted is given, which is 25 kilowatt, and the N is 300 RPM. Right. So P is equal to 60P divided by 2 pi N. If you substitute that value, 60 into your power value is given as power is 25 kilowatt, right? 25 into 10 to the power 3 divided by 2 pi into N value is 300, right? 300. Now if you substitute that, you get the value of torque as 79.6 Newton meter. 79.6 Newton meter, which is equal to 79600 Newton millimeter. Okay. If you substitute that value in the previous equation, the 79600 is equal to 0.255 into 0.55 into 0.1 into 1.125 R2 square. Substituting this one, you will get the value for R2. Okay. And then substitute here, solve R2, you get it as 96 mm. Again, substituting it in the first condition, in the R1 value, you get it as 2. Okay. So that's it. That is the first part of the question. Also find the axial plus W order, substitute the values and find the axial. Directly see how the value to find it and complete the. So that's it. Now the first part of clutch. Single plate plus next day we will look into multi-plate plus. Okay, design as well as the problem related to multi-plate plus. Okay. Thank you.